Hi, and welcome to Calculus Examples. Today we're looking at a limit as x goes to 3 of square root of x plus 6 minus x over x cubed minus 3x squared. So what we are going to start with is what we normally do with limits. We're going to see what happens when we plug the number 3 in, because if we're lucky, everything will just work out nicely. So if we plug in 3, we can see on our top we get square root of 9 minus 3. And in the denominator we have 3 cubed, which is 27, minus 3 times 3 squared, which is also 27. And since the square root of 9 is 3 itself, we end up with 0 over 0. So I'm going to put this in parentheses on the side. It's good that we tried this because knowing that it's 0 over 0 gives us permission to use a nice L'Hopital's rule on this. And if we didn't know that, we wouldn't know that we could actually use that there. Okay, so the next thing that we're going to do before we actually take the limit, I'm going to do one small thing, and I encourage everybody to do this on a regular basis, is when you're working through the algebra of these types of problems, we want to take our square root and turn it into a 1/2 we see there as an exponent, because it is so much easier to take a derivative of something to a 1/2 instead of the sine square root. It's a little bit harder to determine what's going on. All right, so now that we have that, we can apply L'Hopital's rule. If you recall, L-hops we can apply when we have 0 over 0 and a couple other things like infinity over infinity and so on and so forth. Our limit stays the same. The only difference is we take the derivative of our numerator and the derivative of our denominator, and we're going to take those separately. So in our numerator, we're going to bring our power down and subtract 1 to get our new power. But of course, since we have more than just a plain old x in here, we're actually going to have to multiply by the derivative of the inside because we're looking at a chain rule there. The derivative of the inside, derivative of x is 1, and the derivative of 6 is 0 because any constant goes to 0 when we take its derivative. So in fact, you have to write the times 1 if you want to. And as we said, the derivative of x is 1. So there's the derivative of our numerator. On our denominator, we're going to bring our power down, subtract 1 to get our new derivative down here. And same thing for the second term. We're going to take our power down, subtract 1. Now this looks a lot better. Let's clean it up just a little bit. We're just 1/2 x plus 6. And let's just leave it to the negative 1/2 minus 1 over 3x squared minus 6x. All right, now at every step here, we do want to see, does this limit actually exist? So now we're going to plug in that 3 again. So we get 3 plus 6 to the negative 1/2 minus 1 over 3 times 3 squared minus 3 times 6. All right, this looks a little bit more promising. Now, the negative in our exponent here, what that tells us is that we are in the denominator, because just remember that if we have x to the negative a, that is the same as 1 over x to the a. Now we want to be careful here because although it's in the denominator of the first part of our fraction. I'm going to take our it's 3 plus 6 and add that to give us 9. And so we're just going to leave it right here on the top. And notice we have 3 times, however you want to do this is fine. The denominator is pretty quick from this point, right? Because we see we've got 1/2 on top. 9 square root of 9 is 3. So that is 1/2 times 1/3 minus 9. 3 times 9 is 27. minus 18. I'm going to keep this on one page here. When we are multiplying our fractions, we are just going to multiply our denominators there. In our numerator, 1 times 1 is 1. And I hope you're okay. I know you're probably going to do this a lot quicker than me. I like to go through all the steps and show it all out. On our second term on the top there, instead of writing 1, I'm going to write 6 over 6 so that we see when we're subtracting. 27 minus 18, let's actually do that right now. 7, 8, 9. So we have a negative 5/6 over 9. And I know that looks a bit weird, but notice we have a fraction on top. And if we do this right, our 9 is really a 9 over 1. So we've got a fraction on the bottom. And if you will recall, and I know fractions are like one of the hardest things to work with as a mathematician sometimes. We forget how they work. So if we have A over B divided by C over D, we can just flip it and change our division sign to a multiplication sign. So that's what we're going to do here. So that means we get a negative 5 on our numerator and a 9 times 6, 5. So then we're going to get 54 on our denominator. And there is our solution there. You'll notice that there's a lot of algebra that we went through in the last bit of this. So these things are really important to practice whenever you're taking a calculus course. The rules that we wrote up here in pink are also super critical. So keep those in mind as you're working. It's not such a bad idea also to have it written out next to you, just to have that nice reminder as you're working through your homework problems. If you have it right there, eventually you'll remember it and it'll be easy and you will no longer need that card anymore. Thank you so much for listening.